Have you ever wondered how a chemical plant automatically maintains the required temperature, pressure, or flow? The answer is a control loop. A control loop continuously measures the process, compares the actual value with the desired value, and makes correction automatically. A control loop is a system used to automatically control a process variable. The basic principle is simple. Measure the process, compare the measured value with the desired value, and make a correction. A typical control loop has four important parts. The sensor or transmitter measures the process variable. The controller compares the measurement with the set point and determines what correction is required. The control valve or other final control element that then changes the process. The process responds and measurement is sent back again. Two important terms in control system are set point and process variable. The set point where SP is the desired value. The process variable where PV is the actual measured value. For example, if the required temperature is 80 degrees Celsius but the actual temperature is 75 degrees, the controller detects a difference and takes corrective actions. The control loop continuously repeats four basic steps. First, the transmitter measures the process. Second, the controller compares the process variable with the set point. Third, the controller sends an output to the final control element such as control valve. Finally, the process is measured again. This feedback cycle continues automatically. Let's take a simple reactor temperature control example. Suppose the desired temperature is 80 degrees Celsius but the actual temperature falls to 75 degrees. The controller detects that the process temperature is below the set point and increases the heating demand. The steam control valve opens further, more heat is transferred and the reactor temperature starts increasing toward the set point. Now consider the opposite situation. If the set point is 80 degrees but the actual temperature rises to 85 degrees, the controller detects that the process variable is above the set point. It can reduce the heating demand by moving the control valve toward a more close position. The process then moves back to the desired temperature. The easiest way to remember a control loop is the transmitter tells us what is happening, the controller decides what needs to be done, the control valve makes the correction, and feedback checks the result. Measure, compare, correct, and repeat. That is the basic idea behind automatic process control. Follow Industrial Operation Academy for more practical knowledge and on chemical plant operation, instrumentation, process control, and industrial safety.